All right. So in this section, we want to look at lecture 7. Okay. In the other aspect, we looked at how to calculate for the centroid in the various section. This time, we want to look at how to calculate for the centroid, the second moment of area about XX and YY axis, the polar moment of inertia, and also the radius of gyration about both XX and what YY axis. Okay, please take note, this is a past question. And once it's a past question, there is a high possibility that it can still what repeat. So once you have the question like this, let's assume this is your question paper. What do we have to do? You have to put down your given. Okay, you have to put down the given. So our first question says that problem 7.7 show a typical cross section of a T section beam. Determine the following. A, the centroid of the T section, that is Y bar and X bar. Secondly, the second moment of area about XX and YY axis. Also, C says we should calculate for the polar moment of inertia, and D says we should calculate for the radius of gyration about XX and YY axis. So this is our problem over here. You can see we have a T section and the calibrations are in millimeters, which has made life a bit easier since we have been working in millimeters for quite a while now. So the first thing we are supposed to do is we have to pull down our given, okay, so that we don't lose that mark. So this is our given. This is our given. Please, let's do well to do more practice on our own. And also, let's try to work on our speed, okay? Let's try to work on our speed. The other day we met, I realized that the idea was there, but due to lack of practice, some students were struggling. Okay, if you work like that, you will get some to be correct and some to be wrong. Meanwhile, that's not supposed to be the case. Once you have been taught and lecture videos have also been provided to aid your understanding, things should have been much better. Okay, things should have been much better. Yes. So let's all do well to take note of some of these things. And the videos, I'll urge you that anytime you are watching the video, try to take a pen and a paper so that you can jot down some important things. Better still, you are supposed to get a strength of material notebook so that you can be able to use that to keep all the details. Okay. Don't rely on the slide alone. You need a notebook so that you can always refer to. So that you can always refer to. As we are in an examination week, I urge each and every one of us to try our possible best so that we can be compulsive. We should try and adhere to the rules and regulations of the school so that our hard work doesn't get affected by our behaviors. I would advise each and every one of us to try and prepare on our own. Don't rely on anybody. Try as much as possible to do what you can and leave the rest to God. Because if you don't take time and you are done, but you want to help someone, that can lead you into trouble. Okay. So once you are done with the work, try as much as possible to review the work, go over the work over and over and over and over again to be sure of whatever you are writing. All right. So after putting down your given, you realize that our mark is at least we have obtained about let's say a percentage of the mark already. Okay. Yes, as it is in the given, you just put it down. This is XX, and we can see that our YY was running through this lane. Okay, you can put it anywhere. Then from there, from what we learned the other day, from what we learned the other day, I told you that if you are being given the question like this, first of all, we are solving problem A. Okay. So let me quickly put over here. Let me quickly put over here A. Yes. So when you are being given the question like this, you have to just take a critical look at the problem. Okay. And once you have taken a critical look at the problem, you have to know the one that you consider as your part one. You also have to know the one that you consider as your part two. From our previous lessons, as I discussed earlier, I said that if you have something like this, you can still repeat this in your answer booklet. Okay. Feel free to work in it. You can do all your rough works, but make sure that they are precise so that at least even if you are not able to finish, that can be used to check your ideas. Okay. And if some additional marks may have been given or you lose some marks somewhere, um, the examiner may use that to give you some marks. All right. So this is the T section. Okay. This is the T section. So you realize that there are moments of inertia. Okay. There are moments of inertia intersect because at the end of the day, let's say this is a wood, okay, that you want to join together. First of all, you realize that you have to, we discussed from our previous lesson that if we have a problem like this, first of all, the shape that is moving in the hot, the shape that is moving in the x-axis is the one that we are supposed to what? Consider first. Yes. So after from that idea which we know, it implies that the upper one is what we are going to consider at our part one, and then the what? The lower one is what we are going to consider at what? Part two, since that one is moving in the y-axis. Okay. Yes. And this wood that we are seeing over here, uh, let's say that this is going to be our part one. This is going to be our part one because it's moving in the x-axis, x first, then y later. And this one is going to be our hot, our part two. Okay. That one is going to be our part two. This one is going to be our part two. Okay. So you realize that if you want to get a moment of inertia for these sections we are seeing over here, because they are rectangle, if you draw two diagonal lines through them, the point at which they intersect, okay, the point at which the two diagonals intersect can be called or denoted as what? Their center of what? Gravity. Yes, their center of gravity. Over here too, if you take this section too, if you take this section too, and then you try to get its center of gravity, you realize that its center of gravity is going to be somewhere here. It's going to be somewhere in the middle here. Okay. And this wood we are seeing over here, for stability reason, uh, it has overlapped over here. Okay. For it to be more stable, it has to be overlapped. Okay. That is what is happening over there. If you want to consider their center of gravity, you realize that this guy's center of gravity is somewhere here. And this guy's center of gravity is also somewhere here. What do that imply? That implies that their center of gravity is what? Intersects. Okay. And because their center of gravity intersects, it creates what? A straight line through them. And that straight line is our what? Our y-axis. That straight line becomes our what? Our y-axis you are seeing over there. Okay. That straight line become our y-axis. So you can say that we can say that this is our y-axis. Okay. So this y-axis you are seeing at the end of the day, because there is a point over here, there is another point over here. It is going to create a what? Two because anywhere there is a y-axis, you should know that there is surely going to be an x-axis somewhere. Okay. So once these 2 points intersect and it is creating a straight line through them, it means that x-axis runs through the y. Okay. The point of intersection. So that is what it implies. So we can say that this is our hot x-axis. This is also our hot x-axis of the hot part two. Okay, this one is of part one. Yes. So let me quickly clean this and read the note that well so that we proceed. We proceed. So this is our part one, as we discussed earlier. Okay. From there, I just realized one thing. Let me quickly take care of that so that understandings can be clear, and then we see how best we can take it from there. Okay. I said that the point of overlap uh, is going to be somewhere here. Okay. For stability reason, that is what is going to happen over there. Okay. So after putting down your technical diagram, which you want to help you to solve your work, uh, the first thing we have to do is what? The question says we should calculate for what? Our centroid of T section, that is X bar and Y bar. So we have to what? Construct four columns, okay? And with the help of the four columns, we will be able to calculate our X bar and then the Y bar, okay? Yes, as we learned from our previous lectures, okay? So we are determining the centroids, okay? Yes, so we are determining the centroids. Okay, let me quickly make the screen a single slide so that we can quickly accelerate with that. All right. So we say we have to construct four columns. Okay. So we have to construct four columns. So if this is our table, if this is our table, this can be said to be our part. Then from the part, we can come to the area. From the area, we can come to the X. Then later we come to the Y. Okay. Because of the spaces, let's extend it a bit so that we can get some places to write. Okay. Okay. So after constructing the four columns, it means that we have to label the table. Okay. As we learned from previous lectures, we said the first one is our parts. The very first one is our parts. Okay. So we write over here parts. Okay. Then secondly, we come and write over here the area. This is where we calculate the area. And then the area is measured in what? Millimeters. Millimeters squared. Okay. From there, we have to denote our x at infinity. Okay. For the x, it can continue. and it is measured in mm. Also, our y at infinity. Okay. Also, our y at infinity. It is also measured in mm. Good. From there, we can now take, since we have only two parts, we can now take our parts one after the other and see how best we can make meanings out of them. Okay. So let's say this is our part one. This is our part two. Good. So first of all, this implies that our area one, to get the value of our area one, what do we have to do? The area of part one is just, we said that area is equal to what? Length times breadth. Okay. The whole thing over here, if you want to classify part one, if you want to consider part one very well, and you realize that for part one, this is our part one. Okay. This is our part one. And this is our part two over here. This is our part two. Okay. So if you want to consider part one and part two, you realize that for part one, its breadth is what? 100. And the depth over here is what? 20. So to get the area is simply equal to what? The breadth times the depth. Okay. So the area, the formula for the area, let me put it over here for you to see. The area, the area is equal to, let me write it over here for us all to see. The area is equal to the breadth times the depth. Okay. That is the formula for the area. Okay. And the whole of, let me say from here to here of this person is the what? Its breadth. Yes. And its depth becomes what? This part. Okay. Good. So let's what is the breadth of part one? It is let me say 100. Okay. For part one, the breadth is 100 and then the depth is what? 20. So we say 100 times 20. Let's all point that together. 100 times 20. So we're going to write 100 times 20. Okay. And 100 times 20, at the end of the day, you realize that we are going to get our area one to be what? 2000 millimeters squared. 2000 millimeters squared. 2000 millimeters squared. Also from here, we have to come and calculate our x1. Okay. And the value of our x1 is equal to what? It's just the breadth divided by what? 2. Okay. It's just the breadth divided by 2. And what is the value of our breadth? We said that the value of our x becomes what? The breadth divided by what? 2. Okay. Good. So that implies that 100 divided by 2, we are going to get what? That implies that 100 divided by 2, 100 divided by 2, we are going to get our x1 to be what? 50. Okay. We're going to get 50 mm. 50 mm. 50 mm. From here, we can come and also calculate for our y. Okay. And the formula for the y also becomes what? D divided by what? 2. So the y also becomes what? The d divided by what? Divided by 2. Okay. Of this diagram. If you pick part 1 like this, they say here is what? Here is what? Here is 20. Here is 20. And here is the same as what? The D. Okay. And this is the B. And here was what? Here was 100. 100. As simple as this. Good. So that is what we are seeing over there. And the part 1 I'm talking about, this is it. This is part 1. Okay. The shape always the one that is moving in the x-axis is the one we consider first. It's like a rectangle. That is why I'm talking about it in terms of a rectangle. So as you have seen it, the y is going to be what? It's just the d divided by 2. So 20 divided by 2, what are we going to get? We are going to get 10 mm. So it becomes what? This becomes our y1. And the y1 is going to become d divided by 2. Okay. Y1 becomes what? And the d is 20 divided by 2. Okay. At the end of the day, we're going to get 10 mm. We're going to get 10 mm. 10 mm. Okay. From here, the next thing we are supposed to do, we also have to come and consider for our part 2. Then from there, we can just accelerate. Okay. From there, we can just accelerate. So this is our part 2. Let's also calculate for the part 2 and then let's move on. So for the part 2, first of all, we have to calculate for the area, and then later we come and calculate for the x2 and then the y2. Okay. So our area, just the same formula we have been using. Our area 2 is going to be what? Breadth times the what? Depth. Okay. So problem 2, if you want to consider the problem 2, you realize that, or the part 2, how is the shape looking like? For the part 2, its shape is looking like something like this. Okay. For the part 2, its shape is looking like something like this. Because of that, you realize that this is the hot breadth and this is the hot depth. Okay. So let's calibrate it together. You realize that here is what? Here is 100 mm. 100 mm. And here was what? Just 20 mm. Okay. So at the end of the day, if they say the area is equal to what? The breadth times the depth, you realize the formula is going to be 20 times 100. Okay. Yes. So that is the shape for the hot, the part 2 we are talking about. Good. So in writing the answer for that, it's going to become, in writing the answer for that, it's going to become 20 times what? 100. 20 times 100. Because they are all carrying mm. From the laws of indices, the unit is going to become what? Mm squared. Good. So over here too, we are going to get 2000. We are going to get 2000 mm all squared. Okay, good. From there, we can come and calculate for our x2. Because, let me say, they are hot. Their center of gravity intersects. Because the center of gravity of hot, part 1, and that of part 2 intersects. You can see them over here, this guy and this guy intersecting. Because they intersect, it means that if x1 is equal to 60, x2 also be equal to what? 60. That is what it means. Okay, because we said that collinear points or lie on the same straight line and they are what? Equal. Due to that, um, x2 is also going to become what? 100 divided by 2. Okay, 100 divided by 2. If their center of gravities have not intersect, it means that if their center of gravities has not intersect, then it means that the x2 would have become 20 divided by 2. Okay. But because their center of gravity uh, has intersect, that is why it is causing that. Okay. It would have become that. Okay. So uh, now we are getting 100 divided by 2. At the end of the day, if we divide, you realize that our x2, the answer is going to be what? 50 mm. 50 mm. Good. From here, um, we have to calculate for our y2. Okay. We have to calculate for our y2. And our y2, as we discussed earlier, because a different part has been added to it, you realize that the y, we said the formula for the y is d divided by 2. Okay. So if this is our part 2 and our d is 100, it means that we are going to write 100 what? Divided by 2. Okay. But you realize that a different part has been added. It means that part 1 has been added to part 2. So at the end of the day, the weight is going to affect the whole part 1 and part 2. Due to that, we have to add the hot. We have to add the depth of hot part 2 to it. Okay, which is 20. Okay. So the formula of hot part y now is 2 of part y is going to become hot. 100 divided by 2 plus hot 20. Okay. So let's all quickly point that together. 100 divided by 2 plus 20. And at the end of the day, you realize that you're going to get 70 mm. Your y2 is going to be 70 mm. 70 mm. Good. From here, we have to come and calculate for our centroid. Okay. From here, we have to now calculate for our centroid, and then we can quickly accelerate it, then we move. Good. So the aim of the work, we should calculate for the x bar and then the y bar. The formula for the y or the formula for the x bar is giving us this. The formula for the x bar is giving us this. Let me quickly use two slides. The formula for the x bar is giving us this. X at infinity. Okay. The formula for the x bar is given as this. The sum of area at infinity times what? Times x at infinity. Times x at infinity. Okay. All over the sum of area at infinity. Okay. From that, let's quickly substitute our equation into the formula and then we see how best we can be able to move. This implies that our y bar is equal to what? A1 plus A2. A1 plus A2. Please let's quickly take our jota so that once I'm writing and I'm moving, you can be pausing the video and you can also be writing along. And that is the best way that your understanding can be enhanced. Okay. But if you don't take a pen and a paper and you write as I write, to be comparing, you are going to be facing challenges. Okay. Yes. Okay. So this is expressed as what? A1, A1 times what? X1. Okay. Plus A2 times what? X2 because we only have two parts. Okay. That is the meaning of the infinity. If there were more parts, it would have proceeded that way. Okay. So from here, this implies that our y bar, we just have to substitute uh, the formula into it to make life easier. Okay. To make life easier. What was the value we had for our A1? We had 2000 and our A2 we had 2000. Okay. So it implies that for the denominator, we're going to write 2000 plus 2000. 2000 plus 2000. And then the numerator, we have to express it as first one is what? 2000 times the x1. And what is the value of the x1? The x1 was 50. Okay, let's move to our table and see. You realize that our x1 over here is 50. Okay, and the x2 is also 50. So let's quickly pull out into it. This was 50. Let's close the bracket plus another 2000 times what? 50. So this is 2000 times 50. Okay. At the end of the day, what are you going to get? Let's all quickly point this together on the calculator. Let's all quickly point this together on the calculator. So 2000 times 50, all into bracket, plus another 2000 times 50, all into bracket, all over 2000 plus 2000. If you input it into the calculator, you realize that your y bar is going to be what? 50 mm. Okay, just 50. So it's going to be what? 50 mm. 50 mm. Okay. From there, we have to also come and do same for the y and also calculate for our what? Our y bar too. Okay, then it means that we are done with the part A of the question. Okay, so from here, it implies that our y bar, our y bar, what is going to be the formula for our y bar? We do the same thing for the y bar too. Okay, and the y bar is also going to become what? Y bar is also going to be equal to what? That is what? Sum of area. Okay, sum of area at what? Infinity. Okay, times the y at what? Infinity. Okay, there is a dot over here, which is denoting a multiplication sign. Okay, all over the area at what? Infinity. All over the area at what? Infinity. It's just a matter of substitution to just break down the formulas. Okay, then from there you just uh, move. Okay, this that I've written can also be expressed as what? A1 plus what? A2 at the denominator. Okay. Also, 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 the numerator can also be expressed as what? Let's open a bracket. A1 times what? Y1. Okay. Plus, plus A2 times what? Y2. So it's a matter of substitution. Just as we did for the first one, we will do the same thing for the second one too. Okay, good. So from there, it implies that uh, the value of our A1 and A2 was what? 2000. Okay, 2000 each. So this means that my denominator, I'm going to write 2000 plus 2000. Okay, 2000 plus what? 2000. Then the numerator is going to become what? 2000 times the value of what? Y1. Okay. And what is the value of our Y1? It's just 10. Okay. You can see it over there in the table. It is 10. Plus, what is the value of our A2? Our A2 is also 2000. Our A2 is just 2000. Okay. Times the Y2. And what is the value of our Y2? Our Y2 we had 70. 70. Okay. So you quickly punch this into the calculator and you realize that our hot, our Y, our Y bar is going to become, let's all quickly do that together. Let's all quickly do. So after that, you realize that your answer is going to be 40 mm. Okay. You're going to get 40 mm. Okay. You're going to get 40 mm as it is as that you are seeing. So this is our question. And then you realize that we put down a given. We came to put down a sub diagram to help us understand the work. And also, what did we do next? We came to put down our table. Okay. After putting our table, we calculate for our y bar, our x bar, and then we have also now come and calculated for our y bar. Okay, and that is what question one is telling us to calculate for. You see, the A is saying we should calculate for the centroid of T section. So we are done calculating for the centroid, which is the what? X bar and what? The Y bar. Good. So it means that this time we are supposed to go and calculate for B, which is the what? Second moment of area about XX and what? YY axis. Okay. So that is where we have not learned yet. And then that is what you are going to be learning now. Okay. Good. Let me quickly take a single page and then let's see how best we can be able to make things better. Okay, so this is our B, okay? And in the B part of the question, we said that we are calculating for the what? Moment of area about, so let's all put this down together. So we are saying we are doing what? Calculation of what? The calculation of what? Moment, moment of area. Comma, at what? X and what? Okay. So we are rather calculating for the what? The second moment of area. We are rather calculating for the second moment of area. So calculation of second moment of area. Second, second moment, second moment of area. Second moment of area. Okay. That is moment of inertia at what? XX and YY. Okay, good. So first of all, let's do for what? XX first. Then later we come and do for the what? YY. So let's pick this guy first. Okay, good. And the formula for second moment of area about XX. Okay, so we want to talk about what? About XX. We want to talk about the about what? Second moment of area about what? XX. That is what we want to talk about first. About the XX axis. Okay. So this is the first person we want to talk about. So first of all, we have to put down the formula. Okay, and the formula for that is given us what? Is given as this. Is given as okay. So the moment of inertia of what? Part two at what? Um. Okay, we are doing for XX rather. Okay, so it's supposed to be It's supposed to be XX. Okay. So this one is also going to be XX. Okay. But the part two of the hot XX. Okay. Good. So from here, we have to come and calculate for 1% first. Then later we go and calculate for what? The other. First of all, we have to come and find for this. Then later we go and find for the hot. The rest. So first of all, we are calculating for second moment of area about SS. Okay. And the second moment of area about SS is expressed as what? Moment of inertia at XS is equal to the moment of inertia of part one of the area of hot XX plus the moment of inertia of part two at the area of hot XX. Okay. So we have to solve them bit by bit. Okay. So this implies that our XX, this first one that I have underlined, okay, is the part one. Okay, the one denotes the part one. Okay, so we want to, this is part one, this is part one, this is part two. Okay, so we want to solve part one first. Okay, and the part one, the part one, which is I of this into bracket XX. Let me denote it well so that it won't confuse us. Okay, so this one, that is what I'm coming to solve now. Okay, and the formula is giving us, the formula is giving us what? The formula is giving us this. It's equal to what? From what we learned earlier. Okay, all over what? 12. Because it's a rectangle. Okay, to calculate for the hot ij of the part 1, we have to use this formula. BD cube over 12. Okay, plus the area of the hot part 1. Okay, times what? Y1 minus Y bar. Okay, all squared. All squared. From here, it's a matter of substitution. Okay, we just have to quickly substitute our parameters into the answer and then we can just move forward. Okay, so this that we are having over here, the value of our B of the part 1. Okay, we are still solving part 1. Okay, the value of our B of the part 1 was what? It was 100. Okay, come and see. Of the part 1, it was 100. This is it over here. The part 1, it was 100. B was what? 100 and D was what? 20. So let's quickly come and do that over here. So this become what? 100 times what? Because the 20 is cube, we have to put it into bracket so that if you are punching it in the calculator, we don't face challenges. Okay, cube all over what? 12. The area was 2000. We all know already. So all over 12. Okay, plus 2000. Okay, plus 2000. Okay, bracket open. What is the value of our y bar? Our y1. Our y1, it was just what? D divided by 2, and our D was 20. 20 divided by 2, we had 10. Okay, so our y1 of the part 1, 20 divided by 2 is 10. So it's 10 minus what? Minus our y bar. Okay, 10 minus our y bar. And our y bar, we had 40 mm. Okay, so let's quickly put it in there. So this was 40. Okay, at the end of the day, all squared. After punching all of this into the calculator, you realize that let's all punch this into the calculator together. Let's all quickly punch this into the calculator together. Okay. So first of all, when you pick up your calculator, you press on. After that, you press the division symbol. Okay. When the division symbol comes, you realize that the cursor is on the numerator. So you punch 100 times, open a bracket, 20. Okay. Then you close the bracket. You raise to the exponent of 3. Okay. Or come down. You bring cursor down to the denominator all over 12 plus hot, shift cursor to the right hand side, plus 2000, open a bracket, 10 minus hot, 40, square the bracket, close the bracket and square it. Then you realize that you're going to get, you're going to get what? 1, 8, 6, 6, 6, 6, 6. Okay. Point, another hot, 6, 6 hot, 7. Okay. Now, I don't want my answer to be like this. I want my answer to be in a standard form. Okay, I don't want to leave my answer in so many decimals like that, like this. So because of that, what am I supposed to do? I'm supposed to write it in decimal, in standard form. Due to that, I have to shift this hot decimal point to this part. Okay, so in doing so, let's all do that together. That is going to become what? 1, 2, 3, 4, 5, 6. Okay. So you realize that I have to take 6 turns before it finally came to land over here. So it implies that this answer I'm having over here, I can come and rewrite it as what? I can come and rewrite it as what? Let's say my hot. This is now going to be equal to what? 1 point what? 8. I can just choose to write 4 decimal places, okay, for precision purpose. So 4.86667. Okay. Let's maintain it to just 4 decimal places. So let me say 667. Okay. When we took the 10, how many did we had? 1, 2, 3, 4, 5, 6. Okay. So it's going to be times 10 exponent what? 6. Okay. Times 10 exponent 6. And we said our moment of inertia. This time it's not, we are done with center of gravity. So this time we are in moment of inertia. The moment of inertia, the unit for moment of inertia is what? Exponent what? 4. Okay. So we also have to go and calculate for the hot, the part 2. So we also have to come and calculate for the part 2. Okay. We also have to come and calculate for the part 2. And this is it over here. We also have to come and calculate for this guy too. So we are almost done. Okay. We also have to come and calculate for this guy too. In doing so, we have to go and do the same thing we did to the part 1. Okay. So we said our hot. This becomes our hot, our part 2. And the part 2, we are supposed to calculate for our hot, our x, moment of inertia at hot, part 2. Okay. That is the x. Okay. Good. Better still, to avoid confusion, this can also be written as this. Okay. Because there is this bracket sign over here already, I can choose to change the bracket sign so that uh, clarity can be obtained. Okay. So you can see I'm done calculating for this. I have to come and calculate for this guy before I can get the total moment of inertia about XX in the hot, total area of the hot, two sections, okay, of the two parts. So I have to just substitute everything into the equation. So using the parallel axis theorem, my, let me say my X now is going to become what? My moment of inertia at what? Of the part two is what we are calculating now. So in part two, you realize that the shape is no more a hot. This is how the shape look like. The shape of the part two. Okay. If this is the base and this is our depth, you realize that here was what? Here was 100. And here was what? Here was 20. Okay. So this was the part two. This was how the part two looked like. Okay. So knowing this, it means that this time, uh, our formula, just as we did for the first one, it still implies, okay, it still implies. So we say that the moment of inertia at xx, okay, is given as what? BDQ, okay, all over 12 times, or let me say plus what? The area 2, the area what? 2, okay, multiplying what? Y2 minus the Y bar. Okay. The first one was what? Y1 minus Y bar. You see that this one is Y2 minus what? Y bar. Okay. All squared. Okay. So it's a matter of substitution. Let's quickly substitute our parameters into the hot equation and see how best we can be able to move. Okay. So this is now equal to what? What is the value of our base? It's 20. Okay. Good. And our depth become what? 100. So all cube divided by what? 12. Good. From there, plus what? The area 2 to we had 2000. Okay, you could remember we had 2000. Then the y2, the y2 we had 70. Okay, from the table you can see over here, the our y2, the answer for our y2 was what? 70. So it implies that we are going to write 70, 70 minus the y bar. Okay, and the y bar we had 40. 70 minus what? 40. All what? All squared. Okay. So let's all quickly point this into the calculator and let's see the answers we are going to get. Let's all quickly punch all of this into the calculator and let's see the answer you are going to get. Okay. You can just choose to press cursor right and edit the first one. Okay. The first one you did, if only you have not cleaned it, it's just a matter of editing and then you get your answer. If you don't know how to do that approach, then you have to do the traditional way. Okay. It means you have to go all the long way and then retype, type, or punch until you get the answer. Okay. Good. Good. So let's all do that together. And then at the end of the day, if you realize that you're going to get what, let's all do that together. First of all, you punch a division sign and then you type what 20 times what? Brackets open, 100. Okay, close the bracket and then raise to an exponent sign, punch 3 over there. Bring your cursor down, you enter 12. Shift cursor right, plus what? 2000. Okay, then you open a new bracket, or you can punch times before you open a new bracket. 70 minus what? 40. Close the bracket, all squared. At the end of the day, you realize that we are going to get 3, 4, 6, 6, 6, 6, 6. Okay, how many are the six? 1, 2, 3, 4, 5. So it's 5. 1, 2, 3, 4. It's left with 1. Okay, 6. Then a point came. Okay, point what? 6, 6, 7. You can see that the 6 is a recurring decimal. Okay, from there, because we want to write our answer in a standard form, it implies that we have to shift the decimal point in between the 3 and the 4. Okay, so let's do that. That is going to become what? 1, 2, 3, 4, 5, 6. Okay, so when we're writing an answer, I realize that our final answer is going to now become what? Our moment of inertia, okay, of the part 2 at xx is going to be equal to what? 3 points. Let's just maintain 4 decimal places. 4, 6, 6, 7. Okay. Times 10 exponents what? 6. Okay. Exponent what? 4. As simple as that. Okay. As simple as that. Good. So from here, what is the next thing we do? We also have to go and do the same thing that we did. Let's quickly have a look at this. Okay. Let's quickly have a look at this. So we realize that this is our B. Okay. We have to calculate for the second, uh, we have to calculate for the second moment of area. Okay, at x and hot y. First of all, we took the x and realized that to get the x, we have to express the moment of inertia at x as hot. Moment of inertia of part 1 plus what? The moment of inertia of what? Part 2 of the x. Okay, we are done with the x, so we have to come and do the same thing for the hot, the y. This y we are seeing over here. This y I'm just circling. Okay, so we have to come and write hot, about hot. We have to also come and write about y axis. Okay, we have to also come and write about y axis, moment of inertia about y axis. Then we can express it in terms of the formula, and then we also use that to what? Calculate or do our calculation. Okay, good. So we are now going to calculate for the second moment of area about what? Y axis. Okay, okay. So let's quickly take a single page and then let's dive in. So this becomes our hot. Let me quickly take a line. So this becomes our hot. Our hot. Okay, let me just do it simple. Okay. So you also want to do it hot. About hot. about um y, about about axis, y to y axis. Okay. So from there, this is it. Okay. So we also have to do the same thing and express it for it before we can calculate for our total answer. Okay. So this is also expressed as what? Our moment of inertia of part y, which is what? Is equal to what? Moment of inertia of the hot part 1. Okay. In the hot y area. Okay. In the y to y area plus, this could be in brackets. Okay. Plus hot I hot I2 also at hot y to y. Okay. And the 2 simply implies that the part 2. Okay. So after putting this down, we just have to pick them bit by bit and then we solve for them. Okay. So first of all, let's pick this guy. Let's pick the first one. Let's pick part 1. When we are done solving for part 1, we come and pick what? We also come and pick part 2. Okay. We also come and pick part 2. So let's pick part 1. This is part 1. And then later we come and pick part 2. Okay. Good. So our part 1, our I hot, or better still, let me move to a new page. This can be expressed as this can be expressed as what? Of the part 1, okay, can be expressed as this time the sign is going to change, okay, because it's still part 1 we are talking about. Let me quickly put the diagram of the part 1 for you to see. This was part 1, okay. In the part 1, we said that what? Here was what? 20, and here was what? 100, okay. This part was the what? B, and this part was what? D. You see what I'm saying over here? Okay. And this was what? This was the part 1. Okay. This was the part 1. So because we are in YY, the formula changes. Okay. It is no more BD cube all over 12. Okay. This time because I'm talking about the YY as this moment of inertia in the what YY as this of a rectangle. It changes to what? DB cube over 12. Okay. Take note of some of these petty things. Okay. So this time it's going to be what? DB cube. Okay. All over what? 12 times the what? Area. Okay. For the other ones, they still imply. Okay. Yes. Okay. So that's plus the what? Area of the what? Part 1. Bracket open times what? X1 minus what? The X bar. Okay. Good. All squared. All squared. All squared. So from substitution, let's quickly substitute our parameters into the answer and see how best we can be able to move. Okay. So this we just express as this is equal to what is the value of our D? The value of our D is what? From here, the value of our D is 20. Okay. So 20 times what? The B. And the B was what? 100. So 100. Okay. All exponent 3. All over what? 12. Okay. Plus the area 1. The area 1, as we all know, that it was 2000. 2000. 2000. Okay. And then the x1. Our x, we saw that it is hot, this one, because their center of gravity is intersected. They were all 100 divided by 2, which was 50/50. Okay. Yes, our x1 was 50, our x2 was also what? 50. Good. So this is 50 minus what? And then the y bar. Someone may want to challenge or may be getting confused. So let's quickly go and see that. Okay, and verify that. Our x1, what was the answer over here? It was 50. Our x2 was also what? 50. If you can look closely, you'll see that. And our x bar, we had what? We also had 50. Okay. So you can see our x bar over here, we're having what? 50. Okay. Good. And also our x1 was 50. Our x2 was also what? 50. Okay. So let's not get confused at all. Let's not get confused at all. Okay. Let's not get confused at all. So let me quickly denote that and let's see how best we can be able to travel. So this becomes 50 minus 50. Okay. All squared. Okay. At the end of the day, our final answer is going to be in the form of this. We're going to get what? Our I. If we point this in a calculator, all of this, let's all try and punch all of this in a calculator. Let's all punch this in a calculator. And if you point this in a calculator, you realize that you are going to get, let's all do it. 20 times 100 all into bracket exponent 3. Okay. All over 12 plus 2000 bracket open 50 minus 50 all squared. Okay. So this that we are doing, we are still on the part one of it. Okay. I forgot to tell you, but let me just put it over here for you to see. Okay, we are on the part one. So it's just part one. We are on it's just the part one we have taken. Okay. It's just the part one we have taken. So I could also put it somewhere here. Let me say part one. So part one. It's just part one we have taken. Okay. Yes, and that part one was in the form of this. I. Okay. Good. So it's just the part one that we have taken. I can clean this now so that we can move. Okay. Later we'll come and take the part two and we see how best we can be able to travel. So you can see the diagram I've put over there. Okay. So I'm getting, after punching all of this in the calculator, I'm getting 1 6 6 6 6 6 6 6 6. The 6 is 6. Okay. So let's add more. 1, 2, 3, 4, 5. It's left with 1. Another 6 point hot. 6, 6 hot. 7. Now we want to write this in standard form. Because we want to write this in standard form, we have to move this to this. 1, 2, 3, 4, 5, 6. Okay. So you see how our final answer is going to become. Our final answer is now going to become our hot. Our final answer now is going to become 1.6667. Okay. 1.6667. We just want to maintain just 4 decimal places. Okay. Times 10 exponents what? 3. That is the meaning of that. Times 10 exponents. No, it is 10 exponents 6 rather. Okay, because 1, 2, 3, 4, 5, 6. Okay. Times 10 exponent 6. Okay. And you said that the moment of inertia is measured in what? Exponent 4. Good. Good. So we also have to come and do the same thing for the hot, the part 2. Okay. We also have to come and do the same thing for this guy too. And then we see how best he can be able to what? Travel. So in doing so, first of all, this is my hot. This is my part 2. Okay. So I'm taking the part 2 again. And then this is the part 2. Okay. Good. And it is given in a form of something like this. You see that this is 2, then we can open a small bracket. This is it. We have to come and calculate for this guy too. Okay. Then later I can close my bracket. Good. From there, I also have to take it and express it as I did for the initial ones, and then we see how best they can be able to move. Okay. Okay. So first of all, we have to pull down our formula. Okay. First of all, we have to pull down our formula. Times what? Times the area. Times the area of what? Part 2. Okay. All multiplying the hot x2 minus x bar. We are almost done. We are almost done. Okay. All squared. From here, the rest is a matter of substitution. You really have to substitute it into the formula and then you see how best we can move. Okay. So this now can be equal to our part 2. Let me quickly put the shape of the part 2 here for you to see. This is the part 2. The second part we considered. Okay. And the second part we considered is so that if we are saying that this is our breadth and then this is our depth, and here is what? Here is 20, and here is what? 100. What does that imply? Let's substitute that into the formula and see the answers we are going to get. Our denominator, we know that it was 12. Okay. So our D, Our D is what? 100. Okay. Our D is 100. Okay. Times the B. The B was what? 20. You can see it over there. The B is 20. The B is 20. All hot. Cube. All cube. Okay. Times what? The area. The area, we all know that it is what? We had 2,000. Okay. The area of part 2. We had 2,000. Times what? The Y2 was what? 50. Because their center of gravity is intersected, we saw that minus what? 50. Okay. Minus 50. All squared. So let's all quickly point this together on our various devices and let's see the answer we are going to obtain. Let's all point this together. Let's all point this together. So after punching this on the calculator, you realize that we are going to get what? We are going to get, we are going to be getting this answer. Okay. After punching all of this in the calculator, you're going to be getting this answer. Okay. You're going to be getting 6, 6, 6. You can choose to leave your answer in decimals to work with it, or you can also choose to work in standard form. Okay, it's a decision. Once at the end of the day, you're going to get the right answer. We're on your own. Point 6, 6, 6, 6, 4, 7. Okay. To write an answer in a standard form, you realize that you have to move 1, 2, 3, 4. Okay. This one is 4, just 4 decimal places. Okay. But you realize that the brothers are in hot. 6 decimal places. We want all of them to be uniform. Okay. Because we want all of them to be uniform. If not, I would have written 6.6667 times 10 exponent what? 4. But because I don't want that, you can see that the brothers and sisters, okay, this one is in 10 exponent 6. This one too is in 10 exponent 6. This one too is, I want all of them to be uniform. Okay. Because of that, what I want to do is that I want to continue to shift the decimal places so that at the end of the day, I can also get 6 decimal places for this. To get that, realize that first of all, we already obtained 1, 2, 3, 4. Okay, we have to add 2 more so that zeros are going to be introduced. Okay, so 4, 5, okay, 6. Okay, so yeah, the point is going to be somewhere here. How do you write this? Someone is going to be asking or wondering, asking questions. Okay, how do we write this? We can now come and write this in its best way as what? We can come and rewrite this as this. Watch. Better still, you can forward the video a bit by tapping on the screen about 2 or 3 times. You realize that it will forward it so that you don't delay much. So it's going to be 0 point. Then you see this point. What? 0 what? 6. 6. I want only 4 decimal places. So 1, 2, 3. Then I can now bring my 7. Okay. Don't get confused. Times what? 10 exponent 6. Okay, mm exponent what? 4. So I quickly want to just use a two-page slide to show you how far we have come. Okay, to show you how far we have come. So just this is the second part of the work I've taken that we are solving. So we are calculating for the second moment of area at xx and what yy. So we express our formula as this. Okay, first one, we pick the x. We have calculated for it part 1. We have calculated for it what uh, part 2. Okay, as we are all seeing over here. Okay. Also, we also came to pick the what? The y. Okay. We also came to pick the y. And then, as we can see, we have also calculated for it what? Uh, we came to pick the part y over here. We came to pick the part y over here. We have also calculated for it part 1. We also calculate for it what? Part 2. Okay. So the next thing that we're supposed to do is that we just have to come and substitute our what formulas, all the answers we had. We have to come and substitute it into what? Uh, we have to come and substitute it into the various equations to be able to get our final answers, and then we can move. Okay. And then we can move. Okay. So uh, as we did for the first one, as we did for the first one, just as we did for the first one, we have to do the same thing for the second one. Okay. So the part 1, we had 1.86667. Of the part 2 too, we had this answer. Okay. At the end of the day, we are supposed to add it as the formula is saying over here. Okay. But you realize that we didn't do it. So let's just come and do it in our final stage over here, and then we can just wrap up. Okay. So that we can just wrap up. So finally, what are we supposed to do? Finally, what are we supposed to do? We are supposed to just come and add it. Okay. We are supposed to come and add our two parts. Okay. Just as we've calculated for it. So our total is now going to become what? So let's say that we are still on y, so we just have to just calculate it for y just like that, and then so this for the y is going to become what? Because we said from the formula we had, from the overall formula we had that we were using, we said that the second moment of area about what? X. Okay. Or about y. Because we are still on y, I want us to just calculate for y so that we move. This was the formula that we were following. Okay. So we just have to repeat that formula to just evaluate our answer, and then we move. Okay. So watch. We said that what? Our I was equal to this. Okay. So we just have to substitute our answers or our parameters into this final equation. Then we just say that we are done. Okay. So let's quickly substitute our answers into the equation, and then we move. The first one, the the part 1, how did we get? For the part 1, how did we get? We had 1.6667 times 10 exponent 6. Okay. So let's say 1.666 what? 7 times what? 10 exponent what? 6. Okay. Plus the part 2 was what? 0. This was 0.0666 is 7. Okay. Times what? 10 exponents what? 6. Okay. So after adding this, you realize that we are going to get our final answer to be what? We are going to get our final answer to be what? 1.7334. Okay. Times 10 exponent 6 mm exponent what? 4. So you also have to go and do the same thing for the hot x2. Then we can say that we are done. Okay. We also have to go and do the same thing for the x2. Then we can say that uh, we are done with the part B of the question. Okay. We just also go and take the part C and then we see uh, how best we can move. Okay. Then we see how best we can move. Please, I urge each and every one of us to try and solve more examples. Okay. Let's try and solve more examples. Better still, let's look for past questions. Let's look for past questions that we can rely on to make life easier. Okay, good. If you punch, if you punch your answer on a calculator, you realize that you are going to get what? You are going to get, let me say, you are going to get 1733370. Okay, exponent of 4. Okay, this is also accepted. But if you also want to leave your answer in a standard form, this over here, you should know that the point is at the hot far end. Okay, so it's just going to become hot. There is a point over here, 0, 0, 0, 0, 0. So to write this in a standard form, you have to kind of move 1, 2, 3, 4, 5, 6. Okay, and then at the end of the day, that is going to be equal to what? That is going to be equal to what? Let me see, 1.733. Okay, okay. So, or you could just leave it in also just two decimal places, but the three decimal places, okay. The two decimal places, okay. And because uh, I want to just leave my answer in four decimal places, this guy is more than 5. I have to run it to this guy to make it 4. Okay. Due to that, you realize that this is going to be 4. Okay. And if this is 4 times what? I can now bring my times 10 exponent what? 6. Then I bring my unit exponent what? 4. Good. We do the same thing for the hot for xs2 and then uh, we say that we can now say that we are done for the part B. Okay. So let's quickly do the same thing for xs2. Let's do this for what? For xx axis. For xx axis. So you realize that we are still on the B. This one we did right now was for what? For y axis. So this one too is going to be what? The x hot, the ixx is equal to what? The part 1 of that, of the hot xx. plus what? The part 2 of that. Okay. So let's quickly substitute our answers into the or our values into the equation to find for the answer. So this now is equal to what? Which answer did we get for our part 1 of the xx? The part 1 of the xx, you realize that we had what? The part 1, we had 1.8667. 1.8667. So let's come and write that together. We had what? 1.8667. 1.8667. Okay. Times 10 exponent. Times 10 exponent 3. Okay. Plus what? 3.4667. Okay. Times also 10 exponent what? 6. So finally, our answer is going to be equal to this. Let's all point this on the calculator together. Okay. And the part 2 that I'm talking about, the answer I just showed, this is it over here. This is it over here. Yes, that is it over there you are seeing. Okay. So let's all quickly add this together. 1.86667 times 10 exponent 3 plus 3.4667 times 10 exponent 6. At the end of the day, what are we are going to get? What are we going to get? It's 10 exponent 6, please. 10 exponent 6. So at the end of the day, we are going to get 5, 3, 3, 3, 4, hot, 0, 0. So finally, our answer, is going to be equal to what? Finally, our answer is going to be equal to, if you want to write this in standard form, how is it going to look like? If the point is here, 1, 2, 3, 4, 5, 6. Okay. So at the end of the day, you realize that that is going to become what? 5 points what? We just want 3 decimal places, so 5.333 what? 4 times what? 10 exponent what? 6 exponent what? 4. Okay, good. So we are done with the B part of the work. Okay, we are done with the B part of the work. So we just have to move to the C part, and then quickly, we can wrap up, and then we finish for the day. Okay, quickly, we can just wrap up, and then we finish for the day. So you see how far we have come. Okay, you can see how far we have come. If you also have shorter approaches, that is more uh, better than mine, why not? It can also be applied, but make sure that at the end of the day, no matter the shortcut you want to use or the approach, you are still going to get the right answer, and your answers should be what? Meaningful. Okay, your calculation should be meaningful. So the last part is telling us that we should what? Calculate the C say we should calculate the polar moment of inertia. That is what? I subscript ZZ. Okay. So the polar moment of what? Polar moment of inertia. So we have to quickly go and move to calculate for the polar moment of inertia. And that is what? That is C. C. Polar moment of inertia. Polar moment of inertia. So this is our C. C say we should calculate for the polar moment of inertia. Polar moment of inertia. So let's say Polar moment of inertia. Polar moment of inertia into brackets z set. Okay, into bracket z subscript what? Z. Okay, yes. So let's all do that together. Bracket open, we see that what. So this is the symbol for that. So let's quickly move. And this can be expressed as what? This over here can be expressed as moment of inertia at x, total moment of inertia at x, like the what? Total moment of inertia at what? Y. Okay. Our answers are already known. We just had them some few hours ago, few minutes ago. So we just have to substitute them into this equation and then we move. Okay. So the answer we had for the moment of inertia at x was what? 5.3334 times 10 exponent what? 6. So that was what? 5.3334 times 10 exponent what? 10 okay. Plus the y. What was it? It was 1.7334 times 10 exponent 6. We see it. So that was also become 1.7334. It is just 7334. Okay. Times 10 exponent 6. Okay. Times 10 exponent 6. So let's quickly punch all of this in the calculator together and see the answer we're going to get. 5.3334 times 10 exponent 6 plus 1.7334 times 10 exponent 6. Then what are we going to get? We're going to get our answer to the, because we are choosing to leave our answer in standard forms. So that is why at the end of the day, we are getting what? 706,680. Okay. That's if you punch them, if you punch it into the calculator. Because you want to write it in a standard form, it will have to be converted into standard form. And that's going to become what? 1, 2, 3, 4, 5, 6. Okay. So you see how our final answer is going to become. So we can say that finally our what? Our polar moment of inertia. This is no more second moment of area. We are now on polar moment of inertia. 70 point what? 0.668 times what? 10 exponent what? 6. Okay. Exponent 4. So we are done. We are done with our polar moment of what? Inertia. So the next thing we are supposed to go to is to move back to the question. And then we also have to see the last aspect we are supposed to solve for. Okay. And the last aspect we are supposed to calculate for in this question is what? Uh, Radius of gyration about both xs and what? YY axis. So D is the what? Radius of. So you realize that if you don't calculate for, if you're not able to solve for A, you can't solve for B, you can't solve for C, you can't solve for D. It implies like that. Okay. So you have to be able to solve for one before you be able to solve for the other one too. Okay. That is how this particular course has been structured. Okay. Good. So from there, let's quickly come and solve for that, and then we see how best we can wrap up. Okay. So we are on D now, and then the D part of the work says that we should calculate for the what? Radius of gyration. Okay. So D, and the D says we should calculate for the radius of gyration. Radius of gyration. So that becomes the radius of gyration. Radius of gyration. So the radius of gyration, how do we go about it? The formula for the radius of gyration is given as R is equal to the root sign of what? I over what? A. Okay. This is the formula for our radius of gyration. But we have to calculate, that is the general formula, okay? But you have to calculate for the radius of gyration about what? XX. And you also have to come and calculate for the radius of gyration about what? YY. We have to calculate for them one by one like that. Okay. In doing in doing so, what does that imply? That implies that we have to do for what? About X. So this is what I'm writing over here. So I'm coming to do for what? Let me say this is my about what? X axis. Okay. So this is my about X, about my X to X axis. Okay. So the formula implies as what? My R, radius of gyration. Okay. Because I'm talking about the X axis, that is why I've denoted it like this. Is equal to what? The root sign, okay, of I at what? XX, moment of inertia at X, okay, all over what? The area, okay, all over the area, okay, bracket close. So this that we have written over here can be equal to what? You can just substitute everything into this, and at the end of the day, realize that we are going to be getting, we are going to be getting this answer, okay. The area, first one was what? 2000. The other one was also what? 2000. Okay. Area 1 was 2000. Area 2 was also what? 2000. And then the XII. The XII, let me say the moment of inertia at X, at the end of the day, we had what? 5.3334 times 10 exponentially. So we just put that into it. Okay. So 5.3334. Okay. Times 10 exponent 6. At the end of the day, let's all quickly put this into our various calculator, and we see the answer you're going to get. Okay. Let's all point this together on our various calculators, and let's see what we are going to get. Please, if you don't know how to use the calculator, do well to see your friends, okay, so that they can take you through before the due day, okay, before the due day, because you may not be allowed to communicate in the examination hall, okay. So, if your friends are unavailable too, you can see me, okay. I'll do my possible best to take you through. At least I will give you the basics so that if you go, you will be able to do something. Okay, that is the main, most important thing. If you're able to punch it on the calculator, well, then you should be getting this answer. Okay, good. So I'm getting 36.5 what? 36.52. Let me leave my answer in two decimal places. Okay. Or if I want to leave it in four decimal, it's going to be 36.515 what? 1. Okay. Amen. Okay. If you want to leave it in two decimal places, that's going to be 36.52. Okay. Also, let's come and do the same thing. Let's come and do the same thing. Let's come and do the same thing for uh let's come and do the same thing for okay. Just as we did for the first one, we also have to come and do the same thing for the second one too. Okay. So this one too, let's say we do for for y. Okay. So let's say this one is about y axis. Okay. So about y axis. That is the radius of gyration about y axis. Okay. That is what we are on. Okay. So that one too, we have to express the formula as this. Okay. Our r, radius of gyration about y, is giving us this, the root of I. Okay. So this is moment of inertia at y all over the what? The total area. Better still, we can say area at infinity. Then we can close this. Okay. From some substitution, or when we substitute our values into the formula, you realize that at the end of the day, we are going to be getting something like this. Okay. Let's quickly substitute our values into the answer and see what we are going to get. Okay. The first area, how did we get? For the first area, how did we get? We had 2,000. Okay. The second one too, we had 2,000. Okay. So from there, what does that imply? We have to add the two. So it's going to be 2,000 plus what? 2,000. Okay. Good. And then the rest is now going to become the y, what? The let's say this is what? Moment of inertia at y. Okay. And the moment of inertia at y, uh, our answer was the moment of inertia at y, we had what? 1.7334. Okay. We had 1.7334 times what? Times 10 exponent 6. Okay. Times 10 exponent 6. So at the end of the day, let's all quickly point this together and let's see the answer you're going to get. Let's all quickly point this together and let's see the answer you're going to get. If you point this on the calculator, you realize that Let's all quickly point this together and let's see the answer we are going to get. You're going to get, first of all, when you point it, you're going to get 9 root 535 all over 10. Press SD on the calculator. Your answer is going to be what? 20.8171. Okay. What? Just The answer is going to be in Radius of gyration is measured in what? It's measured in Okay. So just as simple as that. So please do well to see your colleagues. Do well to see me in groups, in person, one-on-one. In case you still find challenges with any of any of the areas, so that I'll see how best I can be able to help you or take you through. Okay. I'll also advise each and every one of us to try to comport ourselves in the examination hall. Let's try our possible best to do the best we can do to help ourselves. The exams that you are going to write, your answer booklet is yours. That is what you have paid for the semester. That is the only time you're going to be seeing your answer booklet. Don't be in a hurry to leave your answer booklet. Spend much time with your answer booklet because that is the only time you're going to be seeing it. Talk to your answer booklet. That is what you are paying for. So that at the end of the day, even if you make any mistake, you can be able to rectify that. Okay, most mistake many students do is that in the examination hall, once they are done, they just want to leave quick. But it's a mistake. Don't do that. If the time is not up, don't leave. Okay, try and be able to sit back and go over the work over and over and over and over again, and make sure that there are no hidden mistakes anywhere. Okay, there are no hidden mistakes anywhere, so that at the end of the day, it doesn't affect you. Okay, at the end of the day, it doesn't affect you. Thank you very much for your time. May God richly bless you all too. Bye bye.